Hi everyone, welcome back to my channel. In today's video, we will try to go dive into incremental principal component analysis. So imagine you are working with huge data set, let's say millions of records or images or maybe financial transactions. So the traditional PCA, the traditional principal component analysis, helps us, let's say, to reduce the dimensionality. But with this big data set, let's say it's required loading the whole data set into the memory, which is sometimes it's not practical for large data scale or large data application. This is impossible to load all the data set into the memory. Or maybe another example, if you have, let's say, streaming data. So maybe the whole data it's not, let's say, already ready. So we got, let's see, some other data from social media networks, maybe sensors, and we would like to achieve the principal component analysis. With this stuff we can use incremental principal component analysis. It's not like a normal or a standard PCE. The incremental PCA is learn from the new data step by step, so adapting without needing to recompute everything from scratch. So why it's important? Why the incremental PCA is important? If you have a big data, you would like to process the big data, so it helps you to process the data in chunks instead of all data in at once, or maybe as real-time data. So as I said, you get real data from the sensors, and for the scalability, it works even with a huge data set, and it's memory efficiency. So in this video, we'll go explore the how incremental PCA works, and I will break it down step by step using a clear numerical example and also including with the Python code. And I will show you how to compute and update the principal component incrementally. By end of this video, you will understand why incremental PCA it's not just a theoretical concept, it's a practical solution for handling real data challenges. So before going dive, if you are not subscribed to my channel, please subscribe to my channel because preparing this tutorial it took a lot of time. Okay, let's start. So as you can see, for example, from this image here, you have a lot of data. Sometimes, in reality, we have big data, let's say, collected every day. So to process this, we need somehow efficient way. So this is why we need incremental principal component analysis. So this example here from the Skyline website. I have also added the reference here. So this is applied for iris dataset with the standard principal component, and this is with the incremental dataset. And you can see there is no difference. So let's go dive into the incremental PCA, or it's also called IC. Let's see, IPCA. It's also called like this. So before processing any data, we need to initialize something. The set number of, let's say, of the vector principal components, and the number of principal components. For instance, 1, 2, 3, 4. And in the first step, we will try to process the first batch. We have, let's say, a big data, and the first batch, let's say, it contains some rows or some data. We will calculate the mean, center the data uh, to the mean, and perform the first principal component analysis with singular value decomposition. And for the next step, for the next patch, we will try to update the weight and center the data based on the new weight and project the new data to the principal components, the already calculated from the first patch, and reconstruct the data and calculating the residual, calculating the error of the principal component, then updating the principal component. So I try to write some examples here. It's just a short example, let's see, a simple example, but it will help you to understand the theory behind the principal component. By the way, the standard principal components already loaded, so please have a look because most of the stuff here it's already related to the already explained, let's say, in the standard PCA. So I have, for instance, X and Y. This is batch 1 and batch 2. Let's see, batch 2, and the whole data set is concatenating all of these data. So in the first step, we will calculate the mean of the first data here, the x, xi, x1, let's see, and we will try to center this. So it's 1, the centering, it means 1, the first point, minus the mean. It will be 1 minus 1.5. And the second one, it will be 2 minus 3.5, and etc. You will do it for the all data, for the all data in the x1, and we will try to calculate the principal the the principal component using SVD, singular value decomposition. So let's say this is the Python code that you can do the singular value decomposition. And let's say assume this, we already got the result of this one here, and we will assume this is our principal component U. And for the second batch, we will calculate the mean. For instance, we have x1, x2. This is our second batch, and the mean of the two, it will be this one here. Let's see, and this is our mean one, and this is x1. Now we need to update the mean, so we make it as a global mean. So we will have this formula here, the number of points in the previous batch multiplied by the mean of the first batch, of course, plus the number of records in the second batch multiplied by the mean, divided by number of records. And you can see here, for instance, in our case, sorry, it's jumping. So if you see the x, we have 1, 2, and the second one is 1, 2, two rows. So that's why we have here 2 and 2, and here is the sum of 2, 2 plus 2. So now we will center the data, the mean, to the mean, and project x2, the centered x2, into the current PCA. But with this formula here, multiply the centered x2 multiplied by the already calculated U, or let's see, principal component from the first batch. Now we will try to reconstruct x2. So here we have calculated we projected the x2 to the into the current PCA, and we got this one here. Now we need to reconstruct from this. We would like to construct the x2, the center x2, and see if it's similar, or let's see if it's right, correct. Now we will construct this. Now we need to calculate the residual. So this is our x1, I mean x2 centered. Let's just get from here and minus the reconstructed. And you can see it's 0, 0, and we have this values here. We will try to update so this means it's the third principal component. It has let's say contribute, and we will try to repeat this several times until we get the final principal component. So let me just show you this, or maybe before that, let me just go to the incremental PCA. It's already implemented in this in the skyline, yeah. And you can see this is the example here. Let's try to load the iris dataset, but I already did it in a, let's see, in a different way. So I will show you how I did that. So let's see, we have loaded the data, and as I said, if we have big data, let's see, it's not let's see, possible to load the data. We will try to use a generator, or maybe loading reading from file, let's see, line by line or patch by patch. This is only because the iris data, it's small. So the number of components we would like to extract is 2, and batch size is 10. So each time we will process 10 10 rows, let's see. And this is the incremental principal component. And from here, fit in batch. So as you can see, the difference here, they directly use the X data, the whole X data for the principal component. But in our case, it's I just add this batch in a for loop. So every time we'll try to partial fit the batch, and then after that it will transform the to the data, the entire data set. And this is the second one, the second implementation. Let's see here is the principal component, the normal principal component or standard principal component. And here we try to visualize the data, to visualize the result of both incremental and the standard. And you can see, I can see any difference. Let's see. So that's why it's the incremental principal component, as it could work as the standard one. Let me just remove this. The breakpoint, yeah, it's already. This is the, sorry, this is the standard one, the standard PCA, and this is the, I can, okay, I can, yes. So you can see I can't have any difference. So this also proved that principal component assets could work as a standard PCA. So, but the advantage of using incremental PCA, it's when you have a big data or you have a streaming. I think we got to the end of this. So if you like it, so.